Hey folks, welcome back. This is Joel Mendonca. So I was recently reviewing my routing concepts, right? At the end of the day, routing powers the internet. So this is a quick video on the RIP protocol, right? A very old protocol, but still I thought I'll touch upon it, right? Put in a very simple topology and try to explain some of the basic concepts of RIP, right? RIP is a non-scalable protocol, right? So because you have an upper limit on the number of hops which a network can have, right? It is based on a multicast address based is what I would say, right? The 224, the 009, right? So that's the multicast address used by the RIP updates, right? So when a RIP router wants to advertise any of its network, multicast kind of packets are basically sent, right? They are not broadcast like in the older version of RIP. In RIP version 2, we basically use the multicast based approach, right? Other interesting thing is it's a classless protocol. It means that when the advertisements are sent, the subnet mask is actually sent along with the advertisements, right? So something interesting of that sort. So let's actually go about and configure the RIP protocol. Shall we like look into some of the basic stuff, right? So this is the router. So we have like I said, we have like bunch of routers, 6 routers. And I'm going to start by configuring on my R1, right? Let's do this on R1. Let's quickly see what do we have. Show IP interface brief, right? We have let me just pull this a little bit this side. Yeah, so we have the 10 network. So let's go on configuring. So we would start by saying router RIP, call out the version, which is version 2, and the network command. So network command, what's the use of network command? Network command basically enables RIP and then picks those networks, right? So let's say I'm going to put in the network as 10.0.0.0, right? It's basically class. So when I go and enable it on the 10 network, this is the major network, isn't it? It's a part of which class type? Class A, right? So when I enable it on this particular major network, RIP basically ends up picking the specific networks which are enabled on the interfaces, right? In this case, these are the various subnets under this major network on which RIP is going to be RIP is basically going to be enabled on these interfaces, and these addresses or these networks are going to be advertised, right? So that's interesting. So you just need to remember that the network command doesn't actually mean that you are advertising this network. It basically means that you are enabling RIP, right, on the interfaces which fall under this particular major network. Okay, so that covers the 10 network. I also have 11 networks, so let me enable it on the 11 as well. Good, I think we are good. So that's R1. What do we do on the R2? Pretty much the same. Let's see here. Great. Let's go to the conf mode, router RIP. It's gonna put a version 2 network. What network here? Again, the 10 network, right? Just need to enable it for the major network, and then it takes care of all the subnets inside it, right? So these two are gone. We still have to do it for this one, right? Clearly that's a type C network, so you need to 192.168. You're gonna do it till 23.0 because it has a mask of /24. Sweet, that's good. What do we do now? So we have done it on R1, R2. The next step is probably let's go and check if we can get the routes on R1, right? So we can do show IP protocol. It's a command. So you can see here, RIP has been enabled. Right here, you can see the interfaces on which it has been enabled. Right. On R2, I can also go and do show IP route to see if you are getting the routes from my R1. Am I getting? Yes. So this is actually R1 route. This is also an R1 route, right? Pretty simple. Now, an interesting note which I want to talk here is about summarization, right? So summarization, auto summarization is basically turned on RIP, right? But there is a condition or there is a catch, right? So the auto summarization happens only when you are actually doing or you're crossing the major network boundary, which means here if the route 10.1.1 is actually being sent from R1 to R2, right, there is no cross of boundary because 10.1.1 is and 10.12.12, these both fall under the same major network, which is 10.0.0, right? But whereas the 11 network here, when it is crossing the boundary, right, you are actually going from the 11 network to the 10 network, right? So there is a cross of boundary which happens. So if you carefully view this, the auto summarization happens for the 11 network and not for the 10 network, right? You can see this here. So you can see on R2 we have specific routes for the 10 network, right? You can see the ones which I've highlighted, but when it comes to the 11 network, it has been summarized, right? So that is a condition for the auto summarization, which is actually turned on by default on our RIP. Great. What do we do next? Let's move on to the probably router 3. Right, so let's see if we have everything on my router 3. So let's do enable show IP interface brief. Sorry. Okay, so we have that. We have a bunch of networks. Let's enable it on my R3. How do we do it on R3? Same exercise. Router rep version 2 network. Which network? The 192. So here when you enable, be careful, you need to do it on you have to do it for the major network, right? So here the 23 itself is a major network, right? Even 34 is a major network. Even this, the 3.0 also is a major network. So you do it on that. Whereas for 170 to 16, you have 4, 5, 6, 7, but you can do it only on, you can just do this. This is enough, right? Because this is the major network. You just need to know what is a major network, right? It basically is nothing but the a specific network in your class, right? In the classful kind of addressing scheme. So once you do it on this, all these interfaces will have RIP enabled on them, right? Okay, let's do it on R4 as well. There you go. We did it on R4. So we see certain routes here. So let's go down router RIP version 2. Sorry, network. So network, what do we do here? You're gonna enable it on the 10 network because we have the 10, right? And then the other one is clearly the 192. 68.34.0. Okay, right. So when you come down to R3 now, let's run a show IP route, and what you see here is that it is doing something like load balancing, right, to reach the 10.0 network. So with respect to R3, in order to reach the 10.0.0 network, it can either go through R4 or R2, right? So now let's look at the topology. What's happening here? So R3 actually, because these routes are getting summarized, right, because of auto summarization, the 10 network from R1 and the 10 network from R4 are getting auto summarized, right, when they are reaching R3, right? So as a result of that, what's happening? R3 is not able to understand where the packet has to be sent, right? Because with respect to R3, you just have a summarized network, right? So, R3 will not be able to distinguish, and you have a load balancing situation happening here because with respect to R3, it just knows what is a 10 network. It doesn't know what are the specific routes which are sitting behind R4 and R1, right? And this is not a very ideal situation for me because, I need to have more specific routes to send the packets correctly to the destination. So how do you fix this? You fix this by disabling auto summarization, right? So by doing that, you're basically forcing the routers to send more specific routes, right? So how do you do that? No auto summary. So my bad. Let's go down. No auto summary, right? You just do no auto summary on probably everyone right now, right? Do it here. Do it on R1. Configure router rep and no auto summary, right? So we did it on R1, R2, probably on this one as well, right? So now we did it on that. What do we do now? Probably we can go and clear it. Just do a clear IP route and star, right? Now you do show IP route, right? Now you can see you have specific routes from R3 to reach my R1. So this is basically to reach my R1, and using this you can actually reach my R4. So you have more specific routes now, right? So R3 will be able to do a proper routing, right? So that was basically how you can play around with summarization, auto summarization, how do you disable it and all of that. Moving on, we can also do something like a manual summarization, right? If you want to manually force the summarization to happen, you can do that as well, right? So what we do is we go down to the router 1. Right, let me clear the screen a bit. Let's see how we can do manual summarization. Show IP interface brief. Okay, so let's probably create some loopback addresses. I probably have them here, right? A bunch of loopback addresses. Let me just put them on the router here. Sorry, thing did not get copied. Yeah, there you go. So I've created a bunch of loopback addresses: 172.16, 8.1, 9.1, 10.1, 11.1, right? And I also think I have um, the similar 172 networks from coming in from R3 as well. So if I look at my R2 now, it's going to be pretty interesting. If I look at my R2, if I do a show IP route, what's going to happen in my show IP route here? Yeah. So we just have 4, 5, 6, 7. Okay, so I have just created the loopbacks on R1, but I did not advertise them yet, or I did not enable them for RIP. So I will go to router RIP. I'm going to do a network. What do we do? 172.16 0.0, right? So we have enabled it there, which means I can go down now here, clear the screen and see if we have got it. Yes, so you can see here under 172 we have all these networks, right? The 4 of them are actually coming in from my 4, 5, 6, 7 is coming in from my R1, and 8, 9, 10, 11 is actually coming in from my R3, right? Now I really don't want to have so many routes in my table, right? Basically increases my routing table. So what if I want to manually force let me just create a new file here. Yeah, what if I manually want to kind of like force the summarization to happen here, right? Remember, we have disabled the auto summarization, but you really want to force the summarization. So in that case, what you could do is, let me just paste a bunch of things here and then explain what I'm trying to do, right? Yeah, so I've actually pasted the 4 addresses, right? Basically, which I have enabled on probably the 4, 5, 6, 7, and then you have the 8 and 9, 10, right? So these addresses are basically on my R3, and I also have the ones on R1. Just let's put it inside. Great. So what I've done is I've just written down the binary notation of these addresses, right? I'm not concerned about the 172 and 16. I've just expanded, I would say, the 4 and 0 here, right? So this is 4, this is 5, 6, and 7. Similarly, this is 8, 9, and 10, and 11, right? Now my idea is to summarize. So when I'm summarizing, the first step is we need to figure out what are the common bits, right? So out of this 8 bits, you can see the first 6 bits are basically common, right? Only the last 2 bits are toggling. Pretty much the same case down here as well, right? So yeah, so when you summarize, you just need to know 2 things. You need to know what is the summary address. So the summary address will be like in this case the first address, right? In this case the 4.0, and the summary mask. You need to know the summary mask. The summary mask is nothing but 255, because you want the first octet to be the same. It's 255 again because you want the second octet also to be the same. Whereas in the third octet, the 6 bits are same, right? So you're gonna, if I have to put this, it's going to be like 6 ones and the 2 zeros, right? And the last one is again, the 0, the host bit. Yeah, so if you convert this into decimal, it's basically going to give you 255, 255, 252.0, right? So this is how you summarize. Similar thing works down here as well, so I'll not do it explicitly, but let me continue. So now in order to summarize, what will I do is I'll go on my R1. Let me clear the screen a bit. So let me go down to the interface, which is interface Ethernet 0/0. It is that, right? Because I'm on my R1. This is, yeah, that's good. On that interface, I'm going to do IP summary address protocol. What is a protocol? RIP, the starting address, right? And on my R1 I have these addresses, so it's going to be very similar to this. Let me just paste it here, but the starting address is going to be just 8, right? Great. So this is going to be my address, and the subnet mask is going to be, the mask is going to be this one. Great. Yeah, so now you can see the magic happening. So you see, we had so many routes here. Let me just do clear IP route here once, put in a star, and now let's see the route. You can see the routes have been summarized. All the all the routes which were from 8, 9, 10 and 11, I have forced them to be summarized, and you can see they have been summarized. So we basically reduce the entries, right? We reduce those 4 entries into just 1 entry. So this is nothing but manual summarization, right? And the manual summarization, you always do it under the interface. So you go to the interface and you explicitly define what is a summary address, and this is how you figure out your summary address and your summary mask, right? The whole idea is basically to come up with one address which can represent a bunch of addresses. That is summarization for you. Okay, great. Yeah, let's move on. Let's move on to probably another few concepts which I want to touch upon. As you know, RIP is basically a UDP based protocol, right? So there are no acknowledgements, and that is one of the reasons why RIP basically ends up sending the whole routing table, right, during the updates. The whole routing table is sent. As a result of that, the CPU utilization is more. As a result of that, again, the convergence is not faster, and all of those things comes up, right? It's a very legacy kind of a protocol is what I would say, RIP, right? um, in EHRP OSPF you had the whole neighborship concept, but here you don't have that. So if I have to recap, in EHRP OSPF you have the concept of hellos and keep arrives, which will kind of like check if your neighbor is up or down, and if the neighbor is up, you just send, you don't send the whole routing table, you basically send the updates, right? You just send the only specific changes which has happened in your network to your neighbor. But in case of RIP, you don't do that, you send the whole routing table. Okay, let's also look into authentication, right? Pretty interesting. So let's say you want to put in some authentication, let's say you're between R1 and R2. How do you do that? The first step is you go and define your keychain, right? Start with ABC, probably put in the key ID, and then you put your key string. Key string, probably put in a Cisco, right? Let me also just enable, probably let me just configure and then enable, right? So let's go to configure interface Ethernet 0/0. The IP RIP authentication command is important. There are two ways of doing authentication. One is a clear text and one is the MD5 hashed one. So let me just do clear text to start with, right? So I've done this. Now if I do a debug of IP RIP, like, I can show you some fun stuff. Okay, we'll probably end up getting see, you can see here there is an invalid authentication happening. The reason is because I have enabled authentication on one side and not on the other, so I'll have to do that here. Let's go and do that as well. I believe, okay, I need to, before this I need to do the keychain part, right? The keychain name can be it's not it's just locally significant. The key ID is important and the key string also is important. Just got to use the same thing. Probably clear the screen a bit, go down to the interface, which is 0/0 IP RIP authentication keychain, and it's, I forgot it. What was my keychain? Was it ABB? It was BBB. Okay, sorry. Authentication. Sorry. Great. So once I did this, now you can see that we will start sending updates and everything will be successful, right? So you can see here the updates are being sent now, and you're also receiving updates. You'll start receiving updates as well, right, without any error. You can see here there are no more errors being shown, right? So that's what I wanted to show you. Now you can do the same thing with hashing. So what we did now was basically clear text password. For hashing, the only extra command which you need to do is that you go under the interface, you say IP RIP authentication mode MD5, as simple as that, right? You'll have to put this on the other side as well, interface 0/0, and you just put it here as well. There you go. So now you have hashed it, right? So the passwords will not be sent in clear text. People will not be able to snoop and read your passwords. You have hashed it, right? So that's something interesting. What else? What do we do next? Let's also talk about passive interfaces. Passive interfaces by default, when you enter or when you enable RIP on an interface, it starts sending, and receiving updates on the interface. It starts sending especially your multicast updates on the interface. But what if you imagine your R1 here is connected to bunch of networks which are endos, right? Endpoints or endos, and you're not running RIP on them. So there is no point in sending updates on those interfaces, right? So if you want to stop sending multicast updates, right, to your NOs, then what you can do is you can make that interface as passive interface, right? So by doing that, you will be stopping your multicast update. So I can show you that. So let's go down to my R1. Let's clear the screen. The best way of doing this is probably making all the interfaces on RIP. So what I'll do is router RIP passive interface default. By doing this, all my interfaces became now passive, which means none of them are sending multicast updates. But I do want my multicast update to be sent on this particular interface. I don't want them on the other ones, but I want it only on this. So now I can do no passive interface. So you put in no passive interface and the interface being Ethernet 0/0, right? By doing this, what we have actually done is we have prevented the multicast updates being sent to all the endos. Rather, we are sending it only through this interface where it is needed, right? I can actually do debug here, right? So we'll be able to see the multicast updates being sent only on that interface. Right, so this is received. You can see here, this is the multicast update being sent. Right, so that's how you do it. Now that is interesting. Another way, or there might be another use case where you might ask, do we have unicast routing? Yes, RIP also has unicast routing, which means, let's also consider the use case. R1 wants to talk to only R2, right? You want the RIP to be enabled only between this and this, but you don't want the RIP updates to be sent to R3 and R4, right? So now you can't use multicast, because if you send a multicast packet, then everyone will be able to see it. So you want to send it only specific between R1 and R2. How do we do that? We can do that as well. So let's look at that. So to do that, we'll have to use the neighbor command, right? So let's go down to my R1 again, clear the screen a bit, go to router rep, right? Let's go to the neighbor command. And what is my neighbor? 10.112.12.1, which is my 12.2, sorry, this is my R2, right? So now by doing this, what we have done is we are actually sending two updates. We are sending the multicast updates from earlier, because this interface is not passive. We have made it no passive, right? So we are sending multicast updates as well as we are sending the unicast updates. But like I said, I don't want the multicast updates. So in that case, now I can make my I can remove my passive interface command, right? So basically end up making let's probably I'll have to just remove the passive interface command. So let me make it everything passive interface default, right? So by doing this, show run section router, yeah, there you go. So all the interfaces are passive now, and you can see from now on the updates which will be sent, it's going to be just one update, right? We won't have any multicast updates. You can see here we have just the unicast updates being sent and no multicast updates, right? So a combination of your passive interface command, right? When you use the passive interface command along with your neighbor command, you can make the whole RIP act as if it is a unicast based protocol.